Innate helps companies avoid project surprises, make better informed decisions, share knowledge, and deliver better outcomes. Innate, transforming the way the world builds.
Hello, project people. Welcome back to a brand new episode of the Project Chatter podcast. It's always good to have you with us, and we have a full house. I missed last week, but I did get to hear some of the banter, so thanks, Dale. Dale, how are you, sir?
I'm good, thank you. Thanks for showing up, Martin and Val.
We're here. I was there in spirit last week. Anything happening in the UK moment?
Not too much. I've got COVID again for the second time round. But
You're kidding.
Yeah, absolutely.
You got a double dose.
A double dose. But it might be this event I went to, put on by this company called nPlan. Yeah,
got to stay away from those.
Martin, how are you, sir?
Yeah, good, thanks. And yourself?
That's good. I'm doing all right. It's good. If anyone's got the live feed or the video, you can see that we've got matching haircuts today. So Martin, in tribute of Martin haircuts, I salute you, sir. And let's introduce our guest today. Alan Mosca, how are you?
I am great, thank you.
I am excited about this topic, and I'm glad I dialed in and didn't sleep in this one. AI and machine learning is an interesting topic. It's all over the place. It's lit up in lights, if you like, particularly for projects who think that tools can solve all things, but I think there's some elements that can't. But before we get into it, mate, how did you start in this? Where did your beginnings occur?
Yeah, how far back do you want me to go? I was born and grew up in Italy.
Yeah, perfect.
I studied in Turin, near the Alps. I studied computer engineering back in Italy, moved to the UK in 2006, if I remember correctly, and then spent a lot of time in computing. So I did high performance computing, so the large supercomputers, did a bit of high frequency trading and hedge fund kind of stuff for 8 years. While I did that, I did a master's and PhD in machine learning theory, and then gave all that life up and wanted to take some risk. So I joined an incubator. The incubator is called Entrepreneur First. At the time, I think they were only in London. They're now all over the place. They're running cohorts everywhere. The premise is that they'll find people that they think have potential as founders, chuck them in a room, turn up the heat, and see what happens, and give them 6 months to come up with a decent idea, and then put them in front of VCs.
Wow. So you've always been a geek, Alan.
Kind of, yeah.
You've loved the tech since the start, really.
Yeah. I recently found photos of me at age 10 or 11 trying to put together a computer, courtesy of my mum.
Incredible. And obviously you're working for an incredible company who's doing some pretty fantastic stuff. So how does machine learning work for the less initiated? Because I think for a lot of people, these are very interesting times, but at least at a baseline, we'd like to have definitions on the podcast, because we're just monkeys. We have no idea, Alan. I didn't even touch a computer really till I was like 24. So I would love to know your definition.
Yeah, so machine learning is fundamentally a bunch of math. So you take lots of numbers that combine together such that they produce an output that says, the typical example when talking about machine learning is, this is a cat or this is a dog. And effectively, you stir the numbers until that output classifies a dog or a cat correctly. And it really is just a large set of numbers. So if you look at, I know that we were talking about the language to image models. Those are just, again, very large sets of numbers. And the trick is you show this pile of that algebra enough examples and enough times that it actually learns to minimize the errors that it makes on classifying things or predicting things.
That's awesome. And then the confusion then, because this is what we talked about before we press record, is AI versus machine learning in terms of, are they the same thing? Can they be used interchangeably, or are they specifically different?
So I think a lot of people use them interchangeably, and in parlance now, there's very little difference in how you use one or the other, but actually you can think of machine learning as a sub branch of AI. AI actually has lots of other things, which traditionally also stem from things like robotics, where there's not so much learning, but planning, for example. Not planning in the project sense, but planning what actions is a robot going to take doesn't involve any machine learning, but that is still AI because it's trying to find an optimal path or things like that. And so AI is a much larger family, of which machine learning is a subset. And then if you want to subset even further, you can subset into deep learning, which is large machine learning models that have lots of layers.
Yeah, that's great. Very clear, Alan. I am on board. The other question I had then around that is the idea of learning. So how is that in the context of math? Because if it's layers of math, how does it learn? What is that process?
So the process is I'll show an input to my machine learning model, which is pile of numbers, and it tells me an output. And that output may be correct or it may be wrong. And it will usually be wrong in a quantifiable way, right? So we have an error function that tells us this is the amount of error that you're making. And then we basically propagate backwards. The algorithm is called back propagation, but we take that error and we move it backwards through all the layers of numbers and adjust those numbers based on the error that they made so that the next time you run it, that error is smaller. Or the next time you run the same input, the error is smaller.
So it's kind of like an iterative process. It goes back and forth.
Very, very iterative. Yeah.
Interesting. I think there's one more for me, and I'll let the rest of this team ask questions. When it comes to projects, obviously, there are a lot of transactional pieces of work. But how do you go about, bringing the subject to light? So when someone is thinking about using machine learning or AI on a project, I imagine that could be at all levels a bit of a difficult conversation. So what is your slapstick 30-second pitch on what machine learning is for the less initiated, and why it would be a valuable thing for a project?
So we typically at nPlan, we pitch machine learning as the way of capturing experience. And that means lots of different things, but technically for us, it means that looking at completed schedules of projects that have finished and with varying degrees of success, and learning which things went well, which things went badly in the project, so that next time we have that experience that's been learned by a model that can generalize to other projects. So for us, it's a way of capturing that experience, which typically, if we think about it, experience with humans is designed to fade out, right? People retire, they take other jobs. And so it has an expiration date, and instead we want to collect it and make it permanent.
Yeah, that's interesting, Alan, if I jump in there, because like Val, or maybe worse than Val, I know even less around this technology space. And so it's quite dangerous. And I'm going to ask these really stupid questions. But for me, the first thing that comes to mind is a lot of people that I deal with still today don't fully understand and appreciate what you've just said there in a basic form. And so, it does lead us back to the topic you've chosen. Does it really make a difference? I think before we even get to does it make a difference, do we have a barrier blocker to it even being considered on projects before it can make a difference? Because one of the things I'm thinking while you're talking there, projects might be thinking, or project leaders or decision makers might be thinking, well, I don't have the luxury or the money to allow some algorithm to learn on my project. while I, conduct a phase of delivery? How long does this take? How much is it going to cost me? All these questions come to mind, and it's not just aimed at the nPlans of the nPlans perhaps, but not nPlan specifically, but just AI and machine learning in general sounds like something so foreign to these project leaders that have been around for decades that it feels like something that's too futuristic for now, if that makes sense.
Yeah, and it's a valid concern, right? And I think a lot of it boils down to the fact that it's a new technology, the fact that it's early days, especially in projects, construction and engineering and infrastructure and all the rest, where adoption is slower than, some maybe more risk-taking disciplines. And I think the analogy that I would like to use here is you don't really need to know how the combustion engine or the electric engine works to be able to drive a car. So the thing that needs to happen is that we make it simple enough that all you need to know is how to hold a steering wheel and how to use the pedals, to continue the analogy, rather than what we used to do in, I don't know, the 1920s, where you'd had to know about how to crank the engine, and half the time it would break down and you'd have to fix it as you're going along. And gradually, with technology maturity, these things start phasing out. I think in terms of having the patience of waiting to be able to develop machine learning on your project, you can actually use previous project, use the history of your organization, use the history of the company, and the history of your projects, so that you're synthesizing that experience that might be missing. And this is something that goes all over the place. We do it for schedules, but I think it's something that I would like to see lots of other companies pop up doing the same thing in different aspects of projects. And in a sense, it's similar to what we do in other industries, where, for example, this happens in manufacturing, where we take previous products and we use what happened in those previous products cumulatively over time to create new learning and new insights into the next product that we build. And that's how we build progressively better and better things.
And if I just continue with this thread, if you're saying, okay, let's use past project data that we've got in the organization, what about the old, I think Paul Googe mentioned it before, the old adage of, garbage in, gospel out. How do we get around that? Because how do we know that the data you're using, you're learning off of, actually contributes to the right outputs?
Yeah, so that is typically a problem with any machine learning, right? Or anything that is based on data. The quality of the data is what drives the quality of the output. And the reality is that if you have lots and lots of data, you can then take an approach of, we'll take everything, including the kitchen sink, and then we'll filter out the things that we think are not good. So a lot of it is based on filtering out data that we find that is bad, or you fix it if you have a way of fixing it. In terms of completed projects, you can think of what is the quality of the actualization of the data that I have, right? We look at what did you plan to do in the beginning and what were your updates along the way, and what is your finalized as-built, as it's sometimes called. We need to know that the quality of the as-built is good, or at the very least that it exists. But also we need additional quality on the input, on making sure that it is correct, right? So, and we see this a lot of time when you think about, bidding and tendering processes. There are sometimes, dynamics in the industry where the contents may not be exactly representative of what the intentions of one or either party is. And so that usually then leads to could lead to bad outputs, but also typically it leads to bad outcomes on a project anyway.
Yeah, that's a good point. Just to jump in there, I was just going to ask one more. I was just looking online. There's a guy called Ben Vlivberg, and he posts all these interesting articles and lectures, and has a very particular voice in the community. We've been trying to get him on the podcast. So Ben, if you're listening, hurry up, mate. But he talks about biases. Do biases affect data the same way they affect people?
I think they affect data in different ways. So from a generic point of view, data is a collection of what people do. So there's actually a fantastic example of Microsoft a couple of years back training a language model on all of Twitter and then putting it on Twitter. And within 24 hours, it went from "I love humans, humans are amazing" to the worst, basically the worst Twitter user in the world. And they had to turn it off after 24 hours. And I think that was an important lesson, right? It's not that the AI method in itself had anything bad in it. It's the fact that it learned from tweets. And tweets can have bad things in them, right? And it just learned all those bad things. So it's important to know that the data does somewhat mirror some of the biases, but also in different ways, right? So whereas in planning, we have typically optimism bias, as well as things like Parkinson's law show up, like you'll see those mapped in the data, but in different ways, right? So the optimism bias means that you have typically a much higher probability of something taking longer than having a probability of it taking less time. And you have to know that this is a bias and be able to adjust for it sometimes if needed, right? So, and this is kind of also where we are generally with artificial intelligence and machine learning. We're not really able to run machine learning and AI at scale without human supervision of some kind, at least, right? So if there isn't anyone who's got a big red button to switch off Microsoft's Twitter bot, then it could have run rampage. I mean, at some point, someone would have banned it at Twitter, I would imagine, and probably very quickly. But then that is still like human supervision, right? And we need a lot of being able to override what the ML does, because if you think about it, like the consequences can be actually pretty bad if you just let the biases run loose, right? So in the case of a Twitter bot, it's just to a certain extent, it maybe offended a few people, but actually it's mostly a funny anecdote, right? It was a bot that got shut down. Microsoft wasted a bit of resources and a bit of money building it. But there can be decisions now, especially if you think about things like healthcare, if you think about things like self-driving cars, where a lot of this can become critical.
Yeah, agreed.
If we think about some of this on major projects, kind of what you're saying there is a lot of the data that's in there at the minute is of varying qualities, which is affecting the output. Is there a point where we think this is likely to change? Because from our experience, certainly Dale and Val, a lot of projects, this data still run off Microsoft Excels, Microsoft projects of varying qualities. Are we always going to have that issue of human intervention when we're trying to sell this to businesses as the way forward? Because your sales pitch there was fantastic. Why wouldn't any business want that? When do we think there's going to be a time when that human intervention just won't be needed, or we're going to be in a mature state, or are we always going to need some kind of holding hand?
So I think the thing that will happen is not that the data quality will improve, but the methods will become way more flexible. So we've started actually doing a lot of work on this, where we are able to ingest and treat much lower and lower quality schedules, for example. There's a limit. There's always a limit. And we often do back and forth rounds with planning teams to try and improve the quality of a schedule before we actually release a forecast, which is part of also the human supervision. There's probably an automation will come to rescue a lot of these things. Right? So we're actually going to release a tool for schedule integrity for free for anyone that uses nPlan, so that they can self-serve and be able to improve the schedule quality without having to go back and forth with us to build a little bit of that automation. And I think it's actually going to come this way with the ingestion mechanisms and our ability to interpret looser and more ill-defined or ill-described data to the point where we can then trust it. And I think the important word here is trust, right? And I know that our event last week was titled "Trust between different parties in projects," but actually there needs to be the same thing needs to happen with machine learning and humans, right? So a lot of it is also being able to let go of the handles, and let sometimes the machine learning tell you things that maybe you don't know how it figured it out. It's hard. It's hard to, especially if you've done things for many, many years, it's hard to sort of let go. But actually, when you do let go and only look at the output rather than inspect how did it get there, because you always have the option to ignore things and ignore recommendations that you get from a machine learning model. It's not like all of a sudden we're saying, just let ML run the whole projects and connect all the machinery up to one central brain and everything is automated. So you no longer have a say. But when you let go of that, let's inspect it. Why did it say this? I don't believe it. And actually look at all the downstream things. You can probably ignore some things, right? And that is still something that is very important, because from our perspective, our forecasting engine doesn't know a lot of things about the context of the project, right? So especially things like you've already thought about a risk. So we a lot of the time we highlight risks and highlight ways that risks can be mitigated, but it may be that has already happened. And also you just can turn up the dial on the scale, right? So if instead of doing QSRAs or reference class forecasting, you have to go and dig and go and find what are all the similar things to this thing that I'm doing now. Just let the ML do it on everything, and then pick the things that stand out. You're probably more likely to hit some things rather than have to use your brain to think about where I'm going to look. Just look everywhere and then sort. So I went a bit down a side path here, but
no, we love those, Alan. That's all good. The what about I guess with regards to that accumulation? I love the idea with turning up the scale that you can obviously automate and scale, and we all get decision fatigue, Alan, on projects. So hundreds of thousands of decisions are made on projects every single day, and arguably the quantum of them, most of them are ineffective. Is there a way, do you think, that machine learning will understand how humans really do think about decisions and weigh in the possibilities? You mentioned recommendations before. How does that function work, and how would that work in the future?
So I think so. I think the key to understand how decisions or good decisions are made, right? Because you could always flip a coin, and that only half the time leads to a good decision. The key to understanding how to make good decisions is to understand the process that people go through when they're actually thinking about how to make a decision. And usually this is something that comes from design of all places, but it's described as the double diamond. And it's an exercise of going wide with options and then narrowing them down. This is something that is very well known in design. It's something that's starting to appear in lots of other disciplines. And the double diamond is actually something that then can be mapped out. So when I say, let's look at everything in the project, right? That's a way of going wide. You look at everything, and then you look at the impact of mitigating all the things that come out. individually, and you sort and filter by things that have the highest impact, that are feasible, that are not ridiculously expensive, and that the team knows how to do. And when you do that, you come to a much smaller set of actions that are all potentially good. And you can use those as a way of improving the project without making too many decisions. Because you're right, we all get decision fatigue in our lives as well. There's this notion of a decision budget, right? And there are some people that take it to the extreme, right? Why does Mark Zuckerberg always wear the same outfit? Because then he doesn't have to make that decision. And it doesn't take out of his decision budget. Like, it's a little bit OCD about that. It's a little bit over the top, but there's something behind it, right? And I'm not suggesting that we should all dress the same every day.
I think Obama does it as well. Yeah, I've seen this, and apparently there are some studies around willpower as well being the same.
Yeah.
That we have a finite amount of willpower per day, and that if you spend it all trying to do too much with that willpower, you can actually exhaust it, and that's where addictions and other concerns can come from. But you reminded me of another model when you mentioned the double diamond. I was also thinking about the decision process that in marketing and consumerism, as in the buying process decision model, as in what people have to do before they're sold, right? Because there was a great book I read, Sell or Be Sold is a great book for me personally, because I think in everyday transactions, particularly on projects, you're either being sold something or you're selling something. And not necessarily it's the exchange of transactions between humans, but usually when a decision is made, you're presented with information, and a lot of the times that information is complex, and then you have to go through a bit of a process to understand how you make the decision. And not everyone makes it the same way, by the way. So that everyone has their own internal kind of proving system before they go, okay, this is the decision. Some people are really quick. Some people are really slow. Will machine learning offer the variabilities as well and the various what if scenarios, or do you think it's just going to be, hey guys, a bit more prescriptive than descriptive, and we're going to say it's these that you need to go with? What's your view on that?
I think it'll be a bit of both. So there are definitely cases, and the what if scenarios is actually one of those examples that is less machine learning and more AI, right? Because the machine learning learns how to make a forecast, and it tells you this thing is important, but it doesn't know about what are the alternatives. And then you apply artificial intelligence methods to come up with the different scenarios, both in terms of like, what would they look like? And then how do you simulate them, right? And I think we'll see a bit of both, right? And machine learning is actually really good at spotting really complex patterns. So we actually did an experiment. We tried with our models to put schedules in without the text and to see if we could reconstruct what type of project it was just from the shape of the graph. And it works ridiculously accurately, which means that, and we did this just as a proof of concept for us to understand, does the ML in this case actually learn the patterns of what is happening rather than just a description that you then associate with a probability distribution. And it makes it very, very interesting. And there's like lots of other little games that we thought about playing with this. Guess the planner is another one, which we didn't do, but you could theoretically very easily do. And it's very interesting because learning those structures and learning those patterns then gives you, to a certain extent, also the power to build dictionaries of different things. So if you know that this particular shape of structure is how you build a suspension bridge, then you can actually look backwards into data sets, or you can look at the next suspension bridge and say, actually, this doesn't really respect the grammar that the machine learning model has learned. So what are the differences? And you go look at the differences and you say, okay, it's different because, I don't know, it's in a very muddy area, or it's a very long bridge. And you can explain those things away.
I was going to say the interesting point there then is it reminds me a little bit of planning models. When you build out a program, different projects have different types of programs, and planning models are used as the forefront of, well, this is the way it will be delivered, phraseology or whatever's going to be done. With regards to planning itself and schedules, you mentioned that some of the data is important, some of it's not. So from an input perspective, once it understands the pattern, it doesn't necessarily need some of those inputs because it already recognizes the pattern. That pattern recognition is great for data, but one of the big problems with, well, not problems, what's the best way to say this? One of the challenges with projects is they change, and they change a lot. So the volume of change inherently depends on a lot of things: the size of the program, the complexity of what we're trying to deliver, the politics, various other variables, whether it's all being built in one area or if it's split across various locations. How do you deal with the complexity of change? Because change, I feel, is linked to the schedule and program and risk. And I see the application of machine learning is really around risk and schedule today. They're the real kind of meaty things I think machine learning can really add super value because it's repetitive and there's pattern recognition, and there are rules to the game, right? Because obviously you need rules or premises or business rules. But change is something that sometimes isn't as logical as that. It's interpreted different ways. So we have client-based changes, we have contractor-based changes, and then we have commercial-based changes from my perspective. How does that work in your world?
So changes are very frequent. You're right. It's something that happens all over the place all the time. And there's a lot of this that does get encoded, whether explicitly or implicitly, into schedule structure. And if you look at the data that we collect, we actually see schedules evolve over time, right? And you know, if there's a big change order, that will probably reflect maybe a couple of months down the line, because you need time to actually build out that change into the schedule, but it will reflect in a very large schedule change. So that exists in the data a lot of the time, to the point where we now have internal models that we use to try and understand if a project is going to change in the future. It's something that we play around with internally, but for example, we actually have a very high degree of accuracy in being able to tell if certain links or certain activities are going to disappear. And it's actually been doing surprisingly well. It's still in lab environment for us. But this kind of stuff then tells you that change is somewhat, not completely, but somewhat predictable. And maybe it's just so frequent that you can guess that something's going to change and you're probably right. But also knowing if something has changed in the past, does that, and this is actually maybe a question I can turn back to you. Do you think that if there's been a change order in the past 6 months, does that mean that you're more or less likely that there's going to be another change order?
I'll go with the famous "it depends," but I think, you know, in the projects I've worked on, one change is followed by another. And contextually, if it's around software or if it's around delays, you know, usually somewhat when you're trying to crash a schedule, we look at changing and delinking and removing activities that maybe are nice to have, not need to have. Arguably they all are, but sometimes we get a bit detailed in the planning space. But they're very hard to predict. So I'll be very interested in how that actually calculates. So
the way it looks actually is that you have two ways of, you know, it could either mean positive correlation. If you have a change, it means there'll be more changes to come, or it can mean negative correlation. You've done the change and now you don't need it anymore. And it's actually split. So how do you know which case are you in? A lot of the time depends on like what's happened up to that point. And being able to incorporate those time series of change and time series of evolution of a schedule, right? And that is how you can then build patterns that go beyond just the pattern of schedule structure. But you learn all those things just by effectively splitting the data differently and setting different targets to machine learning models. And a lot of the time, if you set it up correctly and you have enough data, you can learn things that actually tell you a lot. actually, you spoke about descoping. We've actually spotted a lot of descoping early on in our projects, to the point where now sometimes our risk engineers like know where to point and say like, maybe this is going to get descoped. Because we also forecast ahead, right? So everything that we do is based around this notion that, you know, we're at a certain point in time and we're looking at what could happen in the future, right? And so by doing that, we have to attach uncertainty to everything, because even at a very, very basic level, any event that hasn't happened yet has to have an uncertainty around it. And we use that as a way of, you know, creating scenarios and all of that. But actually, it tells us what the KPIs for a project are going to look like in 6 months, in 12 months. And we can then tell, well, for example, like, you're going to run out of float a lot faster than you thought. So if you're going to run out of float a lot faster than you thought, what's going to happen? You're probably going to descope. You're going to not do the flower beds or something else, right? Or like, the other thing that happens, you know, there's like double shifting, all these changes that usually happen when you're on the back foot, right? Usually this happens like you've run out of float. You're not gonna run out of float. You've run out of float, and you're gonna pick up the pieces as they fall in your hands to try and put them back up.
How would you go about explaining this stuff to a project director? Let's use a descoping scenario. You've run a load of models. This is saying it's predicting that, you know, this may potentially, based on the data. I imagine that's got some really, really complex formulas that, you know, geniuses like yourself would only understand. How do you almost dumb it down or make it simple, visual for the uninitiated to describe that? Because I imagine, you know, someone with a lot more project experience would be, or could be, quite quick to dismiss it.
Yeah,
how do you kind of go through that process?
Honestly, like, that dismissal happens a lot. And the trick, I guess, is to there's this idea of going to someone's bus stop, which it's another analogy, but effectively, if you want someone to get on your bus, ideological bus, you have to actually go to their bus stop to pick them up first, right? And so there are things that we do and things that we talk about that go more to somebody's bus stop. So before we start introducing these more advanced notions, we'll talk about, this is the risk on your planned critical path. And actually, we know that by simulating, the notion of a planned critical path goes away completely, right? Everything has a criticality probability, and this is something that you find in regular QSRA anyway. But you kind of have to like do that as a second step. First, you have to say, talk about the things that are familiar. Talk about the things that are familiar, and then sort of like boil the frog, I guess. But gradually introduce new concepts that mean that people are looking further and further and further ahead in time rather than at the present day. So it's easier to think about what were the missed starts last month rather than what start dates am I going to miss in 90 days or in the next 90 days, right? So if you start talking about that and then you introduce the next 90 days saying, well, if you miss this, you're going to miss this, 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 and this. And actually these things you're going to miss because that thing that hasn't happened yet is going to take longer. You can start shifting the horizon. Right? You want project teams to think ahead as much as possible. So there's actually this idea of a lag, right? And when I said like you can scale things up, what I would love to see in the hypothetical future is the integration between forecasting, progress tracking, and schedule all completely automated, so that you can actually basically run forecasts every day. And the notion is that if you're running forecasts monthly, right, or risk analysis monthly, you can only take actions that start more than a month ahead, because the data that you have could be up to a month old, which means that there are things that you might want to intervene on that have already happened or have already gone wrong, and you lose that window, which is actually the window that's straight in front of you immediately. So like you want to shorten that as much as possible by creating faster and faster loops. And you can only do that with automation. And to do that, you need machine learning to do the forecasting, but you need also lots of other things like progress tracking. There's a lot of companies out there now doing volumetric tracking with cameras, etc. And that is great because it shortens that loop, right? It short circuits that process. And so integrating all of that in a cycle will actually make it so that maybe project teams of the future will look at today's risk forecast and say, the day after tomorrow, we've got these problems coming up. Let's start getting ahead of them. And that might be enough, right? That might keep them on track.
Alan, that's hell of interesting if I jump back in there. And I actually want to kind of get into or hear from you around some of the problems we have with ML and AI. And maybe this isn't problems with ML and AI specifically itself, but the challenges it has around it. And we've touched a little bit on them. But in my mind, I'm thinking, this is great. The tech sounds great. Everyone should be implementing it. I think a lot of people listening to you are sold. But I think one of the challenges we may find with it is that decision makers, or these sitting in ivory towers, the politicians of the world, the challenge is they don't like the answer that it gives them.
Yeah.
And so why would they use it, right? Because they want this date, they want this cost, they want, etc., right? And so if we apply what you're saying and it gives them this output that suggests what they're saying is incorrect, why should they use it? So I know it sort of comes into a whole sort of behavior side of things, but is that part of the challenge too? And what else do you see as some of the problems and challenges around adoption?
Yeah. Human behavior, like this is part of like actually human biases, if you think about it, right? So the biases that Bent Flyberg talks about actually do, these also fall under that umbrella. And there's like so many types of biases, and they're all incredibly amazing because rationally they shouldn't exist. And it's just from how our brains are structured and how our instincts take over, right? So nobody likes being told they're wrong instinctively, right? It creates a negative internal feedback. It creates problems with self-image. And that's how like you can actually end up holding conflicting ideas, completely conflicting ideas inside your head at the same time that don't reconcile in any way, but you stretch to make them reconcile, because if any of those are not true, then it means something about yourself, right? And this goes really deep, and it's incredibly fascinating. But if you look at it from, politics and, I don't just mean government politics, but also internal politics kind of stuff, I don't think you can solve that with machine learning. You can help bring transparency to the table. Now, when transparency is not welcome, that is a cultural problem, right? And I don't think I can fix culture. I don't think nPlan can fix culture. And to a certain extent, I don't think governments can fix culture, really. You have to like go on such a wider and longer journey, right? You almost, it's going to sound cliche. I'm going to quote Elon Musk. I'm sorry. But he said like, it's easier to wait for people to die out than for them to change. I'm not wishing that to happen, but it is a monumental effort to change cultures. So if you work in a culture where being wrong is stigmatized, you don't want to be wrong. So if you said, and this is true of politicians, right? If a politician is wrong, they get crucified, right? Which is why they hate being wrong. And they'll go to extreme lengths to not say anything that may be taken later on as them being wrong. I don't mind being wrong, because like actually being wrong is how you learn. That's how machine learning learns, right? Being wrong and being right, and knowing about the difference between the two. But bringing transparency, right? It goes even back to that trust equation event that we did. Like, the key is transparency and being able to talk to each other, right? If you have a politician or a P&L owner of some kind saying, no, this needs to be done by the 31st of October. And the team are saying, we're very unlikely to meet that. We need help. And help may come in lots of different ways, right? It can be money, it can be time extensions, it can be extra resources, it can be shifting things around, it can be reducing scope. You want that conversation to happen. To make that conversation happen, you have to change incentives. And you have to change the feedback loops, which is something that, I'm sorry, machine learning can't fix that. And but it is something that we really bump our heads against, right? And we try very, very hard, because if you think about it, fundamentally, what we do means that you're inputting a schedule, and then we're telling project teams, this is how you could go off track with this schedule. And a lot of the time, we encounter resistance with, for example, some planners, actually, like most planners don't do this, but sometimes it happens, right? A planner will take it personally. It's like, oh, but my schedule's great. I ran a QS array and I hit P80. But actually what we're talking about is unknowability of future events, right? And complexity is actually one of the big problems when combined with uncertainty. So if you think about, these enormous schedules, these enormous work plans, you're sampling from a future distribution tens of thousands of times, right? If you're doing 50,000 different things, you should expect at least 1 in 1,000 events to happen a bunch of times. And if a 1 in 1,000 events happen in a schedule that is incredibly linear, because that's what most projects are, very, very linear, if it happens early enough, it's going to move everything else. You can't get away from that. And it's got nothing to do with whether the schedule was good or not, but it's actually to do with the fact that risk exists and uncertainty exists just in nature, in everything that exists in the world. And we try and map that by learning what the outcomes were in the past and learning what the uncertainty in the outcomes was. And so there is a lot of resistance. There's a lot of, but I've been doing this for 20 years. I'm like, great. That means that your input is great. We're not telling you anything about your input. We're telling you that there is uncertainty in the world and you can't get away from it, but you can try and navigate around it.
Will ML and AI, will it change or replace maybe even the role of the risk manager or planner?
I don't think so. I don't think so. So we're not trying to do either of those things. I think there's a lot of stakeholder management, right? We just talked about politics, we talked about culture. People are fundamental. That's why we have a lot of people in our business talking about what our forecasts are and how you can improve the forecast, how you can look at your risks and your uncertainty, what kind of actions you have available, and what does each action mean. The reason is that it isn't that the machine learning can't figure it out by itself in terms of like what is the data and what is the content, but it's a lot of it is what is the context, political, economic, just where you are, geographical, all these kinds of things that mean that certain things can be done, some others can't, but also how do you promote action into a project team? Paradoxically, we could build the best forecasting engine in the world. It could tell you exactly what's going to happen on your project. Second by, we can't, but theoretically we could, or one could. It could tell you everything that's going to happen on your project, second per second, with infinite precision. And if nobody does anything about it, it's still going to happen in that way. And so the most important thing is actually making sure that something happens on the back of it, which is where people come in. And when it comes to planners, planners encode all that information into the schedule. I like to describe the schedule as the causal map of what's going to happen on the project. And it's the best summarization that you can have of a project, right? And that's why we use it, because it contains so much information. And the planners are the people that encode that into the schedule in a way that nobody else can, right? I very much doubt that you could show up with a drawing, some word descriptions, and some quantities, throw in a model, and out comes the schedule. At least not in the near future, not in our lifetimes, mostly because there's so much extra information that is also implied that then gets encoded.
Well, interesting thoughts to ponder on there. But you did bring up Elon Musk, and so
I'm so sorry I did.
no, it's usually Val bringing it up, so that's almost like a prompt, a cue for Val to step in. Val, over to you.
Thanks, mate. Yeah, I planner role is interesting. I think just on the comment on that, I think there is an enhancement to all roles in projects, and I think we'll see more fusion of roles where, hey, by the way, we've simplified the transactional part of most of these roles. Therefore, your role can encompass more. And I am seeing that on projects so that, if you are a project manager now, there's an expectation that you should understand a little bit about technology. If you're a project controls person, same thing. Risk, exactly the same. And I like to think of the planner as now more of a navigator and obviously plotting the course, and they have a deep understanding of where we're going, even if they're not allowed to put in what they want to put in. They know where they're going or where we could be if we needed to change route or change the plan, which is really, really good.
Yeah, and I don't want to change that.
No,
I really don't.
I don't think we need navigators.
I want to elevate them if I can. If I can build tools that elevate the planners, I'd love to do that. But I really don't want to cut them out. I think they're incredibly important.
See, it's not true what they say about podcasts. We give the planners a lot of flack, but today we're empowering them. Come on.
That's because we all were planners before.
They're great. So my follow-on question was scenarios around what you mentioned around machine learning, what good looks like, or what right is and wrong is, what good is and what bad is. Obviously, that's deterministic. But have you done any lab work or even in real life, the scenarios between, because if it's looking for patterns, if you're looking for pattern recognition, then arguably you could look for what was working in a project and what was not working for a project, and then compare the two. Have you been doing that?
So to a certain extent, yes. To a certain extent, that's what our models learn, right? They learn the completion outcomes of activities and milestones and groups of activities. So you have to kind of combine the machine learning and simulation engines and put everything together. But then in the end, you actually do get a view of that, exactly that, right? You can look at hypotheticals, and I actually try to encourage project teams to put as many hypotheticals as they want into our forecasting engine, because that should tell you what are your best options. And I really like this notion of going very wide with options before making decisions. Now, there are limits, and doing this costs time and money, and people don't only have jobs and they want to go home to their families. So obviously there's a limit to how much of that you can do. But that's also where automation comes in. So one of the things that I think we'd like to be doing a lot more of is potentially generating scenarios that we have seen in the past on new projects. And we sometimes, our risk engineers do a lot of that. Our risk engineers do a lot of generating scenarios. It's usually, what if this goes well, what if this goes badly, rather than changing the schedule, right? Typically, we try not to touch the schedule. The only thing that we look at is integrity, and we then still ask the planning team to fix certain integrity things or explain them to us. Rather than touch it ourselves, mostly because you can't export a schedule, an edited schedule, back out of nPlan. But there is a certain amount of creative thinking that goes into what are my options, which is what I would really love to exploit more, and exploit in this case in the positive sense, exploit more of with the project teams.
Yeah, interesting. I was going to ask as well, because You know, a lot of the projects aren't doing well, Alan. I don't know if you've heard on the news, but most projects down south, I don't know how the UK is going, are pretty disastrous. And, you know, it's not, I'm not
No comment.
calling anyone out here. Yeah. And then there's a number of factors. We know this, right? It's not just data and people or the technology or the type of project. There are so many variants. And when they come up, and obviously most projects now these days, from my perspective, are mega projects, right? They're really, really big projects.
Yeah.
They're not small. There are small projects, and arguably they're meant to be a little bit easier. But if you take the handful of big ones, and I know UK's got a whole bunch, we've got a whole bunch down here, and most of them are transport infrastructure or big defense projects. So they come with the territory. They are going to have inherent risks. Some of them we probably already know before we start. But obviously, if we're modeling data from a machine learning perspective, and we're mapping and doing pattern recognition on the past, then how does that become a predictive future? Because are we not just predicating on things that don't necessarily work? For example, when we talk to Dan Patterson, he's kind of lost all faith in the critical path method in its entirety. And I think there's some truth to that, where we have to have a completely logically end-to-end linked program with nth degree activities for the next 4 or 5 years is unbelievably untrue and riddled with change and other problems. What's your view on that?
So I think, and I'm going to say I think, because I've only met Dan once, and it was only for 5 minutes, and then he decided that we're competitors and he didn't want to talk to me anymore. And so this is also a public invitation to let's talk. Let's talk
Dan.
more. Let's maybe do a podcast episode together.
That'd be great.
Yeah, Dan and Bent. That would be great.
Awesome. Done.
So public invitation to do that, or maybe a panel or something like that. That would be. I think that would be a lot of fun, right? And you know, we keep it non-commercial. Nobody's trying to advertise their business, and we actually will have a great discussion. But I think I agree. Critical path methodology was great when you didn't have tools to do a million different versions of something, right? Which kind of, you know, even if you think about Monte Carlo sampling, right? Think of like Primavera risk. You're kind of doing millions of different versions of the same thing. You're doing a restricted set of the versions of the thing because you're not permuting the activities, you're not moving stuff around, but you're changing the durations. So you've got a different version of it every time. If you've got a different version of something every time, the critical path methodology on its own actually limits you to one option versus the millions that you could be looking at, which is, you know, which is actually kind of, you can connect it back to what I said earlier about, you know, we start with talking to people about their planned critical path, but actually we try and move quickly to criticality as a probability, because something may actually be critical a very small number of times, but when it does, it's because it's really blown up and it adds 6 months to the project. And so that will not show up in CPM. And, you know, we kind of go then into black swan theory, and there's like a whole load of things there. But this kind of stuff then starts becoming very important when you have the computational tools to actually do lots of simulations or lots of different hypotheses or versions of something. And I think that is very important. Now we have the computational tools to do this kind of stuff. We should exploit them as much as we can. And this time, I mean it in the bad sense, like make them work, make the computers work.
Yeah, I agree. Because if you think about it, right, rules of the game we kind of talked about before, Alan, and so we're training our machine learning to play a game that we know is already flawed. Sounds kind of counterintuitive if we wanted the maximum benefit for a project. So if we're saying, hey guys, we want a maximum benefit of a project, but you have to learn the best ways or the best patterns in how to deliver in the old way we deliver project, which by the way doesn't actually work because we always end up blowing these projects out. There obviously are quick wins in terms of risk and schedule optimization. But if the rules of the game, i.e. the critical path method or whatever methodology is adopted, is actually part of the problem, could AI be the solver? Could we go back to AI at some point and say, hey, is this the best way to deliver this? Is there a better way? ? And then it goes, absolutely, Val. Talk to Alan.
Yeah, or actually, I think a lot of trying to answer that question of like, is there a better way that you can solve something, is something that Alice are really looking into rather than us. And I think, you know, fortunately, Alice don't think of us as competitors, and we have a relatively good relationship, which is great, because you could potentially, it hasn't happened yet, but you could have, Alice and nPlan on the same project, right? Alice is about optimizing, find the optimal schedule, and then add uncertainty to it, and find one of the ways that you can then really stick to that optimal schedule, right? And the two things are not mutually exclusive in any way. So, yeah. And that brings you multiple benefits to the project, right? You can like bring the plan date in and then look at how doing that changes the tails. And this is something that we're looking into. Like you may want to look at things like insurance, right? Which is something that doesn't really get talked about a lot, doesn't really exist now. Like, can you insure away the tail of the project in terms of cost rather than time, right? Because insurance can't give you back time. But there are things like that you can start thinking about. And I think there was like another part of your question, which you asked earlier, which is, do we know that the future is going to be different in a certain way, right? So, the game, you said the game is rigged, right? And the game, it is rigged a little bit in the sense that, I could, and any of us could look around and just take a basic statistic. And if you say the project is going to be late, just as a statement on any project, you're going to be right a lot of the time, right? And so you could probably go around and, be a risk consultant just by saying it's going to be late. Obviously you can't, right? There's a lot more into it. But you can pretend to be that. And then you might get away with a couple of contracts and get fired in the first week, right? But you would have a certain degree of accuracy just by saying that. So the game is kind of rigged, but actually there are 2 points, right? One is, how do you make it not rigged anymore? How do you change the outcome, right? So like the forecast is a starting point. When we forecast a project at a present point in time, and I'm using the royal we, I don't mean nPlan, I just mean everybody, you're kind of looking at what is the current version of the future, which is like a weird concept, right? But the current version of the future changes all the time. And the trick is you use the current version of the future to know how to make the next version of the future better. Until at some point, right, you're like, the version of the future gets better, the reality gets a little bit worse, and some it converges somewhere in the middle. But actually, like, you've eroded a lot of the initial bad rigging of the game. So that's one thing that I think is important, right? And this is why we don't like to just engage at bidding stage, right? And a lot of people say that, the earlier you are in a project, the more space you have to make changes. That is true. But actually, if you only do it once, I think it's like kind of not as important as just following things along, because your version of the future changes every time. And it could actually get worse. The other trick is that, the ML is not static. It is never static. The way it learns from historical projects, it also learns repeatedly and continuously. So all the updates on a project that I've had up until now also form the data set for the next forecast. So you can look at things that are covariant, I think is the right term, which means they change together. And you look at covariance and you look at correlation as well. And you use that as a way of knowing how that version of the future is going to change. And that maps very well to, for example, new technologies, right? So say that there's some new magic way of pouring concrete and it dries in 20 seconds, right? What you'll actually see from our models is that if you have a concrete pour and a drying period in a schedule, and you have like a ridiculously short drying period, curing period, it'll get flagged, right? Because we'll see that before that there's a lot of pour. And so we'll have a very long tail attached to that. We're probably also a mode in distribution that's very far out in delay, because we learn to map things relatively. But actually, if you do it correctly, like 2, 3, 4 times, that window starts moving in. And it's probably because of new technology. And that doesn't just go into the model for the project, it goes into the model for the whole client. And so that, we very quickly learn. Yeah, sure, it's not forward learning. So we can't tell you that it's going to be a new technology, because otherwise we would have invented it and I would be a trillionaire by inventing all the technologies in advance. But it can adapt very, very quickly, like surprisingly quickly, to effectively new risk patterns, effectively, and new proportional patterns.
Yeah, so it sounds like, and tell me if I'm wrong, but one of the keys to unlocking the rules of the game and to be a bit more effective, if we are constantly changing the current future, which makes sense to me, which we do it on a monthly basis at the moment on most projects. One of the accelerators is, in fact, to increase or widen the input phase of that update cycle and increase the frequency. What I mean by that is that if we had weekly, daily, or even hourly updates, the current future would, one, we'd have probably more present and different scenarios, and two, we'd probably have better leading indicators rather than just focusing on things that we could not change, because by the time we get the information, we've passed the point in which we can actually do any relevant impact, the positive impact. One more I'm going to hand over to Dale is around decision making. One of the inputs that I think would be fantastic, and I call out all project leaders of all various shapes and sizes to do this, is to include the effectiveness of decision making into any log against time, cost, and scope. Why? Because I had a chat with Dan, and we've had a chat with a few people actually, haven't we, Dale? And this is something that isn't very popular, as you would imagine, because what I thought would be great, and I do it even today, and I am getting some progress in Australia around a decision log. So let's say you're presented, Alan, with some information. It could be from machine learning. It could be from a standard schedule. It could be from a great planner. And then it said, hey guys, this is what's happening. This is the information in front of you. What do you want to do about it? You're in a room of decision makers, and they say, based on the information presented, we make X decision. Great. Now, at some point in time, that data may be important, maybe not, but for a planning tool or for a machine learning tool, that is really valuable, because now we have contextual decisions made against time and cost, and we can see whether or not they were effective. And obviously you can see why people don't want to know that, because if you knew if they were ineffective decisions, therefore the leadership team that are actually making the decisions weren't very good, you'd be like, well, see you later. So it hasn't been a very popular idea, but I would love to see that happen. Is that something you guys are looking at as well, decision management?
So not directly. We have, so in our software, we have tools to support decision workflow. What I mean by that is you can record, what risks matter to you and which ones don't, and you record what action you're going to take. So you record like kind of the are you going to do the action? And then you record the state of the action. Was it completed? Was it not completed? We don't quite know the success of the action until much later on. And that is something that we do not have a historic data set for. So we only do this with live projects, the projects that we are currently working on. It's something that has only existed in our product for the last couple of months. And to be frank, it's also something that not every project uses, right? Project teams also have their own tools, or some don't use tools. So the reality is that we're not going to be able to build ML for this for a very long while, mostly because the historic data doesn't exist, right? But I do think that I'm sorry for coming across as a little bit abrasive, but I think you're wrong. I think you're wrong that we have to refer to ML for this. Think of the value that you could have if you had a log of all decisions made, and what were the inputs to those decisions, what were the goals of those decisions, and what was the outcome when you're trying to make a new decision. What's like the best rational thing that you can do is immediately just go search that log. Just go look at that. And I think it's a fantastic tool. And I wish, you're right, I wish that this existed, because you can then build probably the most powerful organizational decision tool that ever existed. The problem, I think, and you're saying that like you've suggested it and people don't like it. And I think the problem is human nature, right? We don't like finding out that we were wrong. So maybe there's a way, you record the outcome anonymously. And this is also something that, we subscribe to a lot in our culture. To be able to have transparency of information, you have to remove blame. And we do this in our culture. We encourage transparency, and it only really works if you're doing these things, if you're bringing transparency because you care, right? If you're doing it because you want to be right, it's going to backfire one way or another. And so I think it's, again, a little bit down to culture setup and being able to incentivize, recording decisions and then looking back at decisions. There's an amazing book called Super Forecasting. You won't be surprised that it's mandated reading at nPlan, but it talks about similar principles, right?
Wow.
It talks about forecasting, but super forecasters are a group of people. This exists, and it's fantastic. I actually spoke to the CEO of a company called Metaculus, who record forecasts from people on very uncertain geopolitical problems. Things like, when will the first fusion power plant spin up, right? That kind of question. And they record a number of answers, and then they look at like who was right, who was wrong. And over time, you can build this profile. And there are certain people who are super forecasters. And super forecasters are very good at giving probabilities to things. So there are some people out there that do this incredibly well. Everybody who makes a forecast likes to think they're a super forecaster. It's probably not true. But if you look at what they do, is they record their forecasts. They look at whether they were right or wrong, and they then change their mind. And being able to change your mind about something without repercussion is also a great way of then having much better outcomes, right? So if you make a decision and a week later you realize, actually, that was not the right decision. I've got all this extra data now. It was a bad idea. Let's change the decision. How many project teams would actually be able to do that?
Yeah, it's good. I'm with you. I'm with you. I like the I'm just thinking as we talk. We can go on for hours, Alan. You know this.
Yeah.
I think
all night.
I think the idea of anonymization is a good one. Like you have to meet in the middle, and I still think there's value there. I mean, it's in PinBook. I mean, these things have already been, the decision log has been around for a long time. It's not something we created new. Anonymizing that and actually having that as an input field would be fantastic. And then sharing that at the time when you want to review the data is really good. And it doesn't have to be machine learning, but it would be a great input to have that along with the risk classification of projects, all the data from the schedules and programs. Absolutely.
Yeah, you want as much data as possible when you're making a decision.
Absolutely. Makes the model better. Dale, over to you.
Yeah, what if we flipped it a bit with the decisions and almost had a playbook? So you could simulate points at which you'd have to make a decision. And you could say, if I took, what are the likely decisions I'd take and what would the impact be? So when you got to that point, if the risk event happened, you knew which the best decision would be to take. Can we get there? And are we close enough? Do we have enough data to simulate outcomes when making decisions?
My answer here is a very emphatic yes, but with a very big asterisk. So I'm actually talking about this at a conference in November called Decision Making Under Deep Uncertainty. And it's a fantastic group because all they do is they think about how do you make decisions when there isn't sufficient data or data is very noisy and decisions like this has never been taken before. And you don't know the outcome because it's going to be in the future. And and you are forced to make decisions sometimes, right? You have no choice. You have to make a decision one way or another.
Pandemic.
Yeah, right. And like they wrote a ton about the pandemic as well, right? And you are forced to make decisions. And I'm giving a talk at this group about, I called it conditional planning. So the thing that I talked about, reducing the time horizon to the forecast and having as fresh data as possible with the forecast updated as fast as possible means that you can look at a much shorter window ahead of time. You can also pre-encode decisions, right? So conditional planning would mean that when you sit down and you create the schedule and you create the plan of how you're going to build something, and you have something that is uncertain, you can then sit down at that point and say, if this goes well, we're going to do it this way. If this goes badly, we're going to do it this other way. It requires more time in planning and design. But quite frankly, it's going to prevent a lot of fights. So I come at it from a different angle. I come at it from my past in hedge funds and high frequency trading, and everything there is rule-based. The best way to make money on the market is you decide what your rules are and you always stick to them. You never improvise. You never make decisions on the spot after the event. You always make all the decisions before, right? So you know when you get in, when you get out, in both cases, up and down, at a very simplistic level if you're buying a stock. And that is the most successful strategy that you can do. You plan everything up front and you make all the decisions up front, because then not only you can be completely systematic about it and consistent, the consistency then gives you data to know how good your decisions are. And then this is the key, right? You iterate the rules. So if you see that your rule is not good and it has a weak point, you change the rule and you've improved. And that's how you build accumulated knowledge, accumulated experience with decision-making. So I think there's a lot of value, and that doesn't have to come from machine learning. It doesn't have to come from automation to a certain extent. Like, you still want the simulation part of it to be able to look at what if, right? This is where what if becomes very, very important. But the decision and the writing of the rules can come from human creativity that then iterates those rules. And that is incredibly valuable. And I think it would be a game changer. So, and I think we can get there. Maybe within the next 5 to 10 years, we might start seeing something like this happening live on projects. And I would love to see that happening.
Wow. Wow. It's real-time lessons learned being implemented while delivering a project, not this kumbaya moment once the ribbon's been cut. I just want to rewind a little bit, Alan. You spoke about how, ML could take into account technology improving. Can it also take into account the variability on capability in human resources delivering projects? Because not all people are built the same. Projects might be similar, but the people delivering them will be different. Yeah,
this is very fair, right? And in fact, we see a lot of it now, right? We're in a situation where the world is spinning back up, but everybody's quit their job. So we're to some extent rehiring and retraining trades, and that takes a lot of time. And these are all new people, right? So they have a lot less experience. They're going to make more mistakes. They're going to be slower, and there's going to be churn because they figured out that that's not what they wanted to do. So you're going to end up in situations that have much higher uncertainty. And so learning, in the same way that you can learn to map very quickly to the new technological platforms, which change your uncertainty profile, you can also learn to adapt very quickly to other events, other factors that change the uncertainty profile, right? I think the important thing here is that there's an uncertainty profile that will change. And when it changes, we need to be able to adapt the models very, very quickly. And so in those cases, right, the covariates become things that have the same project team or have the same subcontractor or are on the same project, or are in the same area, or the same trades, right? Which are all inputs that go into this type of model, right? When you're looking at an activity, you know what kind of trade it is, you know, sometimes you know what subcontractor it is, sometimes you don't. When you don't, you have to be a little bit more generic with the answer. But if that data exists, it goes in and it adds granularity, which means that then you can learn and adapt quickly, right? The key about how do you treat the machine learning is that, unlike the models where you train the model and you cut it once and you make it live and you let people you know, send their description that generates an image, that's the same model, and that model has been around for like a couple of months and it's always the same one. You actually keep updating the model and you build a model that learns from what's been going on in real time. And that I think is a key difference, right, between you know, computer vision models and that kind of stuff, right? And we're fortunate enough that because we have humans in the middle, we can also spot things. So when we know that there is a new technology or there is something that is going to be a problem, and irrespectively it's given or not given the correct amount of risk, then you know how to mark that because you have a project team that can tell you, you know, we had this with a project where this was with a contractor. They were building a building. I can't remember what it was, but it had a comms room, right? And for some reason, this contractor seemed to typically have a lot of complexity around comms rooms. But and in this particular project, we actually flagged it. We said, like, you know what, there's like comms room could be a risk, right? There's still the same network around it, still has a duration. And typically you have problems when this happens. So you might want to look at that. And their response was, well, actually, this is a different comms room because it's mostly empty. We can't know that, but actually you can then feed back very, very, very quickly to the model these new notions that are very specific, right? And it only takes 10 seconds to have that, well, maybe 10 minutes to have that conversation. And then you feed it back in, and the next thing the model's going to say will be something else that may be valuable.
Nice, nice. Yeah, it's an interesting one. Just rewinding a little bit again, that talk you're going to give for those listening, can they find the recording? Will it be live streamed anyway?
I actually don't know. I think it probably won't be recorded. It's also an 8-minute talk, so that'll be a lot of fun, trying to compress all this information in 8 minutes. We're going to write a paper on the back of it, I think. This is a collaboration between our research organization called NERD. I'm going to give them a shout out, the nPlan Experimental Research Department. I'm very proud of that name. And Yal Grushka Cocaine in Darden in Virginia. And we kind of came up with this idea, and she's been a collaborator of ours for a very long time. We're actually also writing another paper together, but I think this will eventually become either a paper or some kind of position article to explain, like, what is the benefit that this could generate, right? And we're looking in research to find ways of actually simulating this. So can we actually look at our historical schedules with all the different monthly updates and try and simulate where the decision points were, and then rewind it and replay it with a conditional schedule, basically. And that's the idea that we're gonna put out. Please don't steal it. I mean, it doesn't matter. It's not. I don't think it's something that we're gonna build and sell as a product. And so, you know, we're going to publish it as research, right? Which means that the world gets it for free anyway. But I think it's something that, you know, it's our attempt to contribute back to the culture of projects and try and make a little dent in it so that it actually gets better.
Amazing, amazing. We love free on the Project Chatter podcast. We also love nerds on the Project Chatter podcast. So shout out to all the nerds. Look, Machine Gun Martin's ready and standing by for his final few questions and the feature. So I'm going to hand over to him, Alan.
Yeah, thanks for that, and thanks for your time throughout the last hour and a bit. It's been a fascinating conversation. Really enjoyed it.
Pleasure's all mine.
And we'll move on to the final feature of the podcast. It's something called Fiverr, 5 quickfire questions all about yourself. So if you're ready and willing, let's make a start.
Let me get comfortable. Okay, ready.
Sitting comfortably now. Okay, question 1. What's your one piece of advice for people new to the project profession?
Look wide at all sorts of options. If you're new, you're going to have less baggage. So use that as an advantage to take more risks.
Interesting.
That's how you differentiate.
Number 2, biggest misconception about machine learning.
Biggest misconception about machine learning is that it can learn anything, and just because it's called machine learning, it's a black box and it's magic. There's a lot that it can't do.
Number 3, biggest hurdle to AI being used on projects.
Culture. We spoke about it a lot. I think it's culture, risk aversion, and not wanting to be wrong and seeing it in that way rather than as a helper.
What would be your book recommendation to our listeners?
So I already made one, Super Forecasting. I think the other one, which is in the same theme, is Noise by Daniel Kahneman, because it's a little bit long and it repeats the concepts a lot of times. So you kind of like can read half of it and you're okay. But it literally talks about uncertainty, right? And so in statistics, you have this notion of variance and bias. And variance is how wide distributions are, and bias is how far away are they from the target, right? And so you can have someone who's like very, very consistent, but always 10 days late, or someone who's averaging in the middle, but very, very inconsistent. And those are two different problems. And it describes those in incredible detail, but also in a very simple way. And it uses lots of different analogies about how humans are really terrible at thinking about noise, variance, uncertainty, and gives a little bit of advice on how to be better at it.
Nice. We'll be sure to stick those in the show notes. And finally, if you had your time again, would you go straight into computer science, engineering, project management, academia, another?
I actually think about that a lot. I've had a weird journey in the sense that I've done a lot of different things that don't relate to each other. I think I am better for it, but none of it was planned. If I could go back, I would probably plan things a little bit more and be a little bit more directed and get to the same place 10 years earlier.
That's the dream.
Use some machine learning in that planning, maybe.
Yeah, exactly.
Awesome. Alan Mosca, it's been such a pleasure and privilege to have you on the show. I've learned so much just listening to you there. And, you know, it's like I say, it's been great to just kick the tires on various topics with you. We definitely have to get you back, and maybe Val, we can organize that panel, that maybe a debate panel, discussion panel of some sorts with all of our tech guests that have been on. We've had Alice on, we've had Dan on, as we said, we've had a whole host of wonderful thought leaders out there in this space. But before we let you go, Alan, any final thoughts you want to leave our listeners with?
I think the thought that I want to leave is, when you have something new in front of you, don't think about what is it going to change, but think about what is going to change if you don't do it. So think about what is going to get worse if you don't embrace change.
Wow. Mic drop.
I made it up on the spot, so I don't.
No, that's awesome. That's awesome. Val, any final thoughts?
No, that's great. I had that same conversation with someone yesterday, Alan. I was like, what happens if we do? What happens if we don't? And I kind of gave him the dichotomy of, well, we really should get started. But it's been a great conversation. I hope we can have some follow-ups. When I'm in London, or if you come down to Aussie, we'll catch up for a beer. And yeah, thanks for your time and your inputs. Really appreciate it.
Thank you. The pleasure's all mine.
Thanks, Alan. So, folks, there you have it. That is all the time we have on this episode. But remember, before you go, please do help us pay it forward by sharing a link to this episode on your favorite social media. Once again, a massive thank you to our guest, Alan Mosca, and thank you all for listening. Till next time, we say stay safe, be disruptive, and have fun doing it. From a full house, myself, Martin, and Val, it's bye for now.